Okay, so right now we're just going to go through questions 1 through 25 on your review sheet that you've already completed to make sure that you have the right answers. If you get something wrong, please erase it and fix it so that you have a really good study guide for what your final is going to look like. On this portion that we're talking about today, you may not use a calculator, okay? So we're going to practice as we go through it with not using our calculators. First one says, find the sum or the difference of the integers. Christopher, same sign or different sign? Different sign. So since it's a different sign, we're going to subtract the numbers and take the sign of the larger number. When you subtract that, what do you get? Okay, and then I saw that you took the sign of the larger number, so the correct answer is negative 45. Okay, so let's go on to the next one. Negative 18 minus negative 13. Heather, what should I do first? Good job. We've got a double negative there, so that is going to be turned into a positive. So now we have negative 18 plus 13. Heather, same sign or different sign? Okay, since it's a different sign, we're going to subtract and take the sign of the larger number. What's the answer? Negative 5 is correct. Okay, looking at the next one, now we're going to be working with fractions and decimals. First things first, I do not want this to be a mixed number. So what will I turn that into? Improper fraction. What is that as an improper fraction? Okay, 13 over 8. Now we already know that it was a negative, so I'm going to keep that negative right there. Plus 1/4. Gerard, what do I have to do now before I can add or subtract those together? Very good. We want to find that common denominator. So when you do that over here, Gerard, what do you get? Okay, very good. So now I have negative 13/8 plus 2/8. Addison, same sign or different sign? Okay, same sign, add and keep, different sign, subtract and take. What did you get? Okay, negative 11/8. As I looked at a lot of your final review sheet, this is the answer I saw. Is that correct?
No.
What's wrong with that?
You have to simplify.
It's improper, so we have to make sure we turn that into a mixed number. If that was a mixed number, what would that be?
Negative 1.
Negative 1 and 3/8. Okay, looking at the next one, I do see that there is a double sign here. Which sign should I keep?
The negative sign.
The negative, because whenever we add a negative, it simply means we are subtracting it. Kaylin, same sign or different sign? Same sign, because remember that saying, guys, every number has a sign, and that sign is directly in front of that number. Good job. So we've got 4.6. We're going to add together 4.32. Kaylin, what should I do?
Drop down your decimal.
Okay.
And then you bring down your 2, and then that's 9. Well, yeah, and then that's 9, and then 4 and 4 is 8.
Okay. And
you do a negative because both of them are negative.
you are correct. Same sign, add and keep. She knew that both of them had the same sign. They were both negative, so we kept the sign. The correct answer is negative 8.92. All right, moving on to the next one. It seemed like some people kind of had a hard time remembering this concept. If you want to, on the side, you can write down this comes from 2.1 and from 2.4. So if that's helpful to you, you could go back to those lessons and rewatch them. But let's look at this first part. Before I do anything else, is this answer going to be positive or negative?
Negative.
It is going to be negative because there's only one negative sign there. So a lot of times I want to just give myself my box and put in a little negative because I know I am going to have a negative answer. Okay? Now we've got 3.3 times 5.2. Lexi, tell us what to do.
Multiply negative 5.2 times 3.3, and then you're going to get 1.9. Wait, this is right.
Let's multiply the 3.3 times the 2 at first.
3.3 times 0.2,
Okay, keep going.
and then 3 times 5 is 15.
Okay, hold on. We're going to multiply this whole number right here times the 2. Okay, now I'm going to put 0 as a placeholder, and instead we're going to go ahead and multiply times this 5. Tell us what to do.
And then multiply the 5 and 2 times
3 times 5 is 15. You carry the 1 up. 3 times 5 is 15 plus 1 is 16. And you add them all together and you get negative 171.6.
Okay, now let's look at this. Up here I can see there was 1 decimal point moved over. This one had 1 decimal point moved over, so I need to move that decimal point a total of 2 times. So where should my decimal point be?
In front of the one.
It would be
Oh, sorry.
in front of the 1.
Okay, and then we know already from the beginning, because there was only 1 negative, we're going to keep that negative. So the correct answer is negative 17.16. Let's move on to the next one. Now we're going to be multiplying fractions. Remember, the only time that you can ever cross-reduce is when you are multiplying fractions. So let's see, is there anything I can reduce here? What can I reduce, guys?
2 and 14 and 4 and 8.
The 2 and the 14. What do the 2 and 14 become?
A 1 and a 7.
A 1 and a 7. How about the 4 and the 8?
1 and a 2.
A 1 and a 2. Is my answer going to be positive or negative? Okay, we do know that it's going to be negative. Now let's multiply across the top and then the bottom. What do I get?
Negative 2 over 7.
Negative 2/7 is correct. Okay, the next one asks us to evaluate the expression. I want us to look at that before anything else. Is the answer going to be positive or negative?
Positive.
Why is it going to be positive?
Because they're 2 negatives.
There's an even amount of negative numbers. So there's a couple ways that you could do this. Sometimes people are like, hey, let me get rid of the negatives. So they would multiply this negative times that negative. If you do that, what do you get? 8. Okay, and then I would still have to bring down my times 5. Guys, what's 8 times 5? 40, okay? So that's the correct answer, but there's another way that you also could have done it if you wanted to go in the order that you see there, because once again, order doesn't matter when you're multiplying. So let's try this. What's negative 4 times 5?
20.
Not 20. Negative 20. Then I still have to bring down my multiply by negative 2. What is negative 20 times negative 2? Positive 40. So notice no matter which way you do it, you should still get that the correct answer is 40. Problem 8 says negative 5 squared. What does negative 5 squared mean?
5 times 5.
Not 5 times 5. Negative 5 times negative 5. If you don't have this part in your notes, I want you to put that in your notes just so it reminds you, oh, that means I am squaring the exact thing that's there in the parentheses. Class, what's negative 5 times negative 5?
Positive 25.
Positive 25, and the reason is there was an even amount of negatives, so your answer is positive. On to the next one, we are finding the quotient. Anson, what's negative 10 divided by positive 2? Negative 5 is correct. On to the next one. I've got a mixed number here, and I don't want that to be a mixed number. So guys, what would that be if I changed that mixed number into an improper fraction?
6 over 3. Negative 3. 5.
It is going to be a negative. Negative what?
5 over 3.
Negative 5 over 3 is correct. Now, we have learned something about dividing fractions. What have we learned?
You can't divide fractions.
You can't divide fractions, so we need to use KFC. Write yourself a little note off to the side to use KFC when you get to a problem like this. We will keep the first one, flip the second one, and change that operation. Zion, what can I cross-reduce? Okay, what do they become? Very good. Would you multiply that out for me, please? Oh, whoops. Sorry, I wanted to change that to a multiply.
8 times minus 8, and then 3 times negative 5, negative 15.
Excellent. And can that be reduced? No, it cannot. So my final answer is 8, or negative 8/15. All right, as we move on to the next section, write the mixed number as a decimal. If you are wondering where to find this in your notes, you would go back to section chapter 2.3. First things first, I've got 4 1/5. Let's turn that into an improper fraction. Class, what would that be as an improper fraction?
21 over 5.
21 over 5 is correct. What does it mean when I have a fraction bar? You can divide, all right? So if you don't know how to do this in your head, 21 divided by 5. I can put a decimal point. In our class, I like to put 3 zeros. You don't have to just put 3 zeros. You could put more, or you could put less. Guys, how many times does a 5 go into a 21? 4 times. What is 4 times 5? 21 minus 20? 1. Bring down that 0. How many times can 5 go into a 10? 2 times 5? 10. All right, so I am finished. And what is my answer? 4.2. Now, does it need to be a negative or does it stay positive? It stays positive. If I had a positive mixed number, I will still have a positive decimal. All right, going on to the next one, let's turn that into an improper fraction. Gerard, what would that be as an improper fraction? Okay, so it's going to be 23 over 10. We know that we're going to keep it as a negative. So now, if you don't know how to do this in your head, 23 divided by 10. Guys, how many times can a 10 go into a 23? 2 times 10? How many times can a 10 go into a 30? All right, remember once you get it down to a 0, you are finished. Is this answer going to be positive or negative? It is going to be negative 2.3. Next one, simplify the expression. This is coming from 3.1. Let's find the like terms. Kaylin, what are my like terms on problem 13?
Negative 8y, negative 2y, and r, and 2y, and negative 25 and 15.
Okay, very good. Now we're going to go ahead and combine these variable terms first. What does the 4r and the 2r become? 6r. And then Kaylin, what's negative 20 plus 15? Negative 5 is correct. All right, on to the next one. Aubrey, tell me what to do.
First you underline the negative 5y and negative 2y, then you circle the positive 6 and positive 3.
Excellent. Let's combine the variable terms first.
That equals negative 7y, and 6 plus 3 equals positive 9.
Very good. All right, for this next one, I do not want to see you underlining and circling whenever we have the parentheses there, okay? So this comes from section 3.2. If you would, remember, we're going to get rid of those parentheses. So do I need the parentheses around this first part right here? No, I do not. So we have permission because there's nothing to distribute to go ahead and drop that down. Do we like it when there's a plus or a minus on the outside of the parentheses? We like to have that plus because that gives us permission that we don't need to change anything on the inside. We can simply drop everything down. Now let's underline and circle the y family and the constant family. Lexi, what is negative 8y minus 2y?
Negative 6y.
Same sign or different sign?
10y. Negative 10y.
Very good. We want to add the numbers and keep the sign. And then Lexi, what's negative 5 plus 6?
Positive 1.
Positive 1. Next up, let's go on to the next one. Addison, do it for me, please. Do I need the parentheses around the first one? Nope, so we're going to drop that down. Tell me what to do next. Okay, very good. There's no need to keep those parentheses, so we're just going to drop it all down. Now, what do you do when you underline and circle? Which ones are like terms? Okay, very good. A positive 10 and a negative 10 are opposites, so they cancel out. Very good. All right, this next one is one of the trickiest things that you're going to find on your final, okay? Because people get really mixed up when there are minus signs in front right here. So first things first, justice, do I need the parentheses on this first part? No, we do not. There's nothing to distribute. There's no negative in front. So I'm just going to drop everything down. Now, we don't like it when there's a minus there. So what do I give you permission to do?
Change it to positive.
Okay, let's change that to a positive. But if I change that to a positive, we have to focus on these signs that we see inside of our parentheses. Guys, what does the negative 3x turn into? Positive 3x. What does the positive 4.1 turn into? Negative 4.1. All right, now this is kind of silly when we see that there's two pluses side by side. We only need one because that simply just means to add. As we underline and circle the like terms, Gerard, what should I do? Okay, what is 6x and 3x? 9x. And then we're going to circle the constants. Same sign or different sign? Same sign. So we're going to add those numbers and keep the sign. Gerard, when you do that, what do you get? Okay, and is that going to be a positive or a negative? That is a negative. All right, just the girls. Do I need the parentheses around the first set?
No.
No, I do not. So I'm just going to drop it down, negative 2y minus 4. Who can help me with what to do next? Kyla, what do I do?
So you change the negative to a positive, and then since there's no sign in front of the 9y, that's just automatically a positive, so you make it a negative, and the positive negative 6 will become a negative 6.
Okay, and then when you see this right here, which sign should I keep?
You should keep the negative.
Keep the negative, okay? Because when you're adding a negative, that simply means to subtract. What should I underline and circle?
Negative 2y, circle negative 4, underline negative 9y, and circle negative 6.
Okay,
Negative 2y plus negative 9y is negative 11y minus 10.
all right, very good, because we were having same sign, add and keep. Add the numbers, keep the sign. All right, number 19 says, simplify the expression using the distributive property. Remember, the distributive property is saying there's a number on the outside of the parentheses that's right next to it, and we need to distribute it or multiply it by every term on the inside. Heather, what's negative 4 times positive 2y? Negative 8y. And Justice, what's negative 4 times negative 3? Positive 12 is correct. Box that in. Now the next one looks a little bit different because I have more things inside of the parentheses. Remember, according to PEMDAS, we do parentheses first. Is there anything that I can combine inside of those parentheses?
6y.
Good job. That's the y family. So we're going to combine those. And then that constant is there kind of all alone by itself. So when you combine those y families, what do you get?
Positive 3y plus 2.
Very good. Now we have a normal problem. Kaylin, do it for me, please.
You do negative 2 times 3y and negative 2 times 3, and you get negative 6y minus 6.
How many of you would say you got that same thing when you tried it on your own? All right, good job. If you did not get that, please erase your answer and fix it for me. If you're struggling with distributive property, this comes from section 3.3. So you could go back and watch that review video to help you just to kind of get that back in your head of how to do distributive property. Okay, so this next one says to write the decimal as a percent. This comes now from chapter 6. So we're moving on to 6.1. What do I need to do with that decimal point, guys?
Bring it back towards.
Move it to the right 2 times, and what's our answer? 5% is correct. The next one, same idea once again, move it over 2 times. What do I get? 68%. All right, moving on to the next one. It says to write the percent as a decimal. This is still from chapter 6.1. What do I do with the decimal now? Good job. So there's an imaginary decimal right here, and we are moving it to the left 2 times. Just the boys, what's the answer? 0.57. And on to the next one. If you are wearing a blue shirt, what is the answer? 0.24 is correct. All right, for the last one today, we're just going to go through these formulas, and then we will be finished for today. The percent of error formula. This is one that a lot of people seem to have a hard time finding. This comes from 6.4. Guys, what is the percent of error formula? Okay, you take the amount of error, or the amount that you got wrong, and then you divide it by the actual amount that was there. And we will have some problems that we'll go over later on in our review sheet that will use this formula. On to the next one. Gerard, what is the simple interest formula? I equals P times R times T. Guys, what did that word P stand for?
Percent.
Not percent. Principal. That's the starting dollar amount that you have. All right, the next one, percent equation. This comes from 6.3. What is that? P times of equals is. And the last one on this slide, what is the percent proportion? Is over of equals P over 100. Remember, if you didn't get those correct, I want you to erase what you have there, fix it, and put this in for me, please. Okay, problem E is asking for theoretical probability. What is that? Okay, favorable over total. Remember, favorable is what you are looking for over or divided by the total or the total amount that's there. Next up, circumference of a circle. There's actually 2. Who can give me one of them?
Times the diameter.
C equals pi times diameter. There's also another one, so you could do either one. Not 2 pi r squared, just C equals 2 times pi times r. All right, the next one, area of a circle. A equals pi times r squared. What does that r stand for? The radius. Good job. How about the area of a square formula? A equals s squared. All right, 2 more formulas, guys. What's the area of a rectangle? Length times the width. And then finally, the area of a triangle. Okay, what does the B and the H stand for? The base and the height. Very good job. So tonight, I want you guys to work on the next 10 problems. You're going to be working on numbers 31 through 40 for your homework in your final review sheet.